Hi everyone, thank you for joining our webinar today. My name is Simon Laird. I'm the services lead here at OneSpatial in Australia. I've been with OneSpatial for a bit over 5 years now, and I've been using FME for longer than that still, with lots of different data problems and challenges that I've solved using FME over that time. Now, today I'm going to talk about the feature merger transformer because I think it's a really handy transformer for many different purposes. The main one being merging features or merging workflow. However, I think it doesn't quite meet the topic of today, which is the transformers on the fringe, because this as a transformer is commonly in the top 10 list of transformers based on user feedback. So if you were joining today hoping to hear about transformers that are rare and uncommon to be seen, this isn't one of them. And it's definitely not on the fringe. I think it deserves a bit of focus because it's a very useful transformer. It's highly configurable, and I'll start to run through some of those aspects that I really like now. So if you've not seen this transformer before, I'd be surprised if you're an FME user. Its most common use case is to merge two different streams of data together. And the way it does that is using either two common attributes, so a common attribute between the two different streams of data. That could be a single attribute, or it also could be a combination of attributes, sort of like a composite key that then describes how the various features in FME can be joined together. It's actually quite powerful and configurable in that way that you can actually modify the attributes from your features as they come into the feature merger to enable them to be merged together. Some examples of this might be to truncate your attributes that you're using to join on, or another one might be to, for example, change the case so that you can make everything uppercase to ensure it joins cleanly. You can do even more complex things with conditional values for your joining attributes. And this might be something complex where you need to determine if an attribute has a value or not, and then you might use a different value in that situation. The cardinality or the type of join can also be configured, so it enables you to do some quite complex joins. However, if you are doing something like this, I don't think it's this as a transformer. The feature merger is probably not the best transformer to use. However, it can handle some quite complex scenarios. The feature merger as well, by default, is a group-based transformer, and what that means is it will wait until it receives all of the features by default in the requester and supplier ports. However, it can be configured to be more like a feature-based transformer, which means that it won't hold all the features at the transformer before it begins to process. And this is using the suppliers first option, which what that means is you need to send and ensure that your supplier features reach the feature merger before the requester features arrive. And this is something that might be very useful from a performance perspective, or just to enable your process to run without requiring quite as much memory. So some other functional uses, things that I really like about the feature merger. It can also do unconditional merging, and this is where you might want to merge everything together without actually using the attributes in your incoming requester or supplier features. For example, you could set the attributes to be 1 and 1, meaning that everything will join. You can also then configure it to do and handle duplicate suppliers. So this is where you have features coming in to the supplier side of the feature merger that have the same attribute that aren't unique. This is something that you can enable the feature merger to support. However, in my opinion, it's something that I think has the possibility to trip up users and cause unexpected behavior. And that's because of the way that when you use duplicate suppliers, it will merge using the first supplier that arrives at the feature merger. So if your data stream varies in its order, you may find yourself in a scenario where you end up with a merge that you weren't quite expecting. In my recommendation, it would always be to process your suppliers before sending them to the feature merger if you have duplicates or you have any other processing you need to do to ensure that you don't need to use the duplicate suppliers option. The other things that are really useful are the unmerged requester and unused supplier ports. So if you were trying to do a very simple and clean merge process or combination process, you'd probably be quite frustrated to find features coming out of these ports, especially the unmerged requester, if you're expecting all your data to merge. However, these can be quite useful ports on these transformers for other uses beyond just trying to join your data. And it might be things like trying to identify non-conformances in your data. So if you've got data that you expect always to join, anything coming out of these ports straight away can give you a quick indication that something's not wrong. Sorry, something's not right with your data. And finally, the other one that I find really useful, which I find myself using more and more frequently now, is using the feature merger as a flow control mechanism within a workspace, which you can see on the slide here. I've got a workspace here, which I'll cover in a bit more detail in a moment. However, what we have in this workspace is two parallel operations happening. Down the bottom, we have an operation happening where we're engaging with an API service, and the top bookmark in a moment, which I'll show you, we have a separate operation working. And the reason that I say flow control is we don't want the final part of the workspace to run until the API operations have finished in their entirety. So just to step into what this workspace looks like, at the very beginning, we're reading in a text file that has some data in it, replacing the geometry from the text file to actually make it into a proper feature. We're then joining it to a database to get some more information, and then using an attribute manager to tidy up the features. We then split the data features into two separate streams. The top one is aggregating all of the features together and accumulating them into a hull based on their geometry. And down the bottom, we're actually then taking those features and using an API service to verify that those point locations are where we expect them to be. And so down the bottom, we're calling an API using a HTTP caller. We're then parsing out the response in the JSON extractor. And then finally, we've got a tester there to tell us whether it's passed or failed. Anything that's failed is coming out in the logger. And then what we've got after the tester is that we have a sampler, and what that sampler is set to do is to only pass through the final one feature. And then we also have an attribute keeper there, which is keeping no attributes because we don't need anything necessarily from this stream of data. All we need at this point is just to know that all of the features have passed through this particular point in our workspace. And then finally, that feature merger there, which we can see in the center there, what that's doing is doing a one-to-one unconditional merge. So what that means is the features that have gone through the hull accumulator, they will not proceed through to the feature writer until that stream of data or stream of features down the bottom, which are going and interacting with an API, have all finished being processed. And then anything that isn't merged, so that would be in a situation where none of the features that have been pushed to that API have passed, meaning that nothing comes through from the sampler and through the attribute keeper to that feature merger, which means that we need to go and review our data. So thank you for listening. I hope you like the feature merger. I find it to be a very useful transformer. I'll now hand over to Sam.
Thanks, Simon. Hi, everyone. My name is James Bottrell. I've been with One Spatial for a few years now as senior consultant. I have a fair bit of FME experience going back to when I was also in natural resources in geoscience. So today I thought my topic of transformers on the fringe would be about inspector. So the concept in general of data inspection for the FME workbench is that you really want to be dealing with the right information at each step of your transformation. That means as you bring on a reader feature type here, you want to be looking at that and being familiar with the content, the geometry, the look and feel of it. You do also have the option to inspect with this feature caching mode when that is turned on by default at each transformer, so you can see the changes as you go. I will introduce another option for you in this presentation about using the dedicated transformer and why I think it's on the fringe. And lastly, you also can inspect your data at the very end, so beginning, during, and end. What are you looking for when you are developing and debugging? Well, the feature information window is a great option to look at your format, your schema, and your geometry. The schema, you have exposed and unexposed attributes. Perhaps you're setting the data type for those in an attribute manager. That will save you from having to do so on the writer, where you can manually configure your user attributes. But we think schema mapping should be performed during a translation with an attribute manager, so you can leave it on automatic when you write the data out. You want to check your geometry types. It might not just be point, line, polygon. You might actually be dealing with multi-parts. You want to check that the data is in the right location on a map. Also, attributes. Inspect and look up where there are issues, such as this example where you've got rejected features coming out an output port and it's telling us the geometry is invalid. I also suggest sorting columns ascending and descending just to get a feel for the values and their statistics perhaps of numbers. Look at the quantity of features going through transformers. Are you losing features? Do the feature counts add up from all the output ports? Compare them to the input. Another option here is with the visual preview that comes in Workbench. Open up the display control, the open table attributes, and the graphics. And there you can actually set some of the symbology, and you can put a base map on the view. It's hidden. Symbology is hidden in this little crosshairs, but here we can set color, choose an icon for a certain point, or set the transparency, which is called opacity here. And lastly, you really want to make sure that the restructured data that you've written out is as you want it. Now, the inspector transformer, it sends features to the data inspector. Data inspector is a separate application to the visual preview. 2018 feature caching mode was introduced. This meant that no longer do you have to place inspector transformers all over the place. So unfortunately, the inspector has become on the fringe, and because you could explore before, during, and after the translation, as I showed earlier. Well, now there are some reasons I think to use inspector. The main one I really like is the ability to use group by. I'll show you that in a minute. Where you're not using the feature cache, perhaps your workspace is processing lots of data and you want to just have a single point in your translation that you want to inspect. Turn off the cache mode and place a inspector down. And you may want to inspect many places in your workspace, so you can also place more than one inspector. Okay, for our demo here, I'd like to go back to a workspace for those that have attended our training. You might be familiar with it. We are looking at some postal address point data over Vancouver, and the idea is to combine some other data, tabular crime data, some open street polygons to community facilities, and some other grouped data over the area for noise control. And we're looking at the distance to some of these features and coming up with a metric. It's a little bit made up, but the metric is this walkability result. So we do a bit of math between some columns to come up with a number, as you can see here, that shows how walkable is it across the city to certain features. And what I'd like to show here is that with inspection, our map here only really shows a certain amount of data, right? So it's not grouped in any way. But an attribute range mapper can help us in that regard, and we can put them into ranges, give them some sort of output. And again, I can't really view it. So adding an inspector transformer and turning on the group by functionality with that new output from the last transformer and running again will actually group the data into different output areas, and I'll be able to select those dynamically in the map and get a much better indication as to where some of these high walkable areas are compared to some of the lower areas, which, provides us a little bit of spatial indication as to a result. Yeah, lastly here, I'd like to recommend an option nicely hidden in FME Workbench, and that is if you close the visual preview plane and hit the crosshair, you can redirect your inspection to go to the dedicated data inspector application. So ticking this on, I think it's on by default now, is super helpful for those with 2 monitors. So I'll pass you over now to my colleague Sam.
Thanks, James. And hello, everyone. My name is Samuel McDonald. I'm one of the engineers and senior consultants working at One Spatial Australia, and I'm also the training manager. Chances are, if you've ever taken training with us or may take training with us, that you've probably come across me before. I joined One Spatial back in 2020, about 5 years now since I've been with One Spatial, and I have 8+ years of FME experience. And I'm here to talk to you about the null attribute mapper transformer, a transformer that I think is fairly misunderstood. To give a simple definition of this transformer, it simplifies the mapping of attributes between specified values. You can target specific attributes or apply it to all, and you can map based on the input attributes having certain null types or certain precise values or matching certain regex expressions. And then you map those to new string values or any of the null types. And as the name would suggest, the transformer is extremely useful when handling any of FME's null types. That would be the null, the empty, and the missing. Now, since this transformer does have a part to play with null types, it's worth understanding those 3 types. So let's talk about them quickly. And the first of them to talk about is the null. How I like to think about the null type is that the attribute exists and it has been assigned a null designator. We agree that we have an attribute and we agree that it has no value. These may sound silly to say it out like this, but all 3 of these types have sort of distinct differences to them, and it's important to understand these differences. Now, for the null type in FME, it's represented with the angular brackets that have null in between them. But to give some comparisons, this would be equivalent if you know Python to create a variable and assign it with none. We are creating X, but it is nothing. Or in SQL, if you were to insert a null value as well. We are inserting something that is specifically null. It is all very deliberate here. The second one is the empty type. And the way I like to think about empty is that the attribute exists, but it has not been assigned a value yet. It's become a string without characters. We agree that we have an attribute, but we haven't actually been bothered to put anything in there. In FME, this will just actually be an empty cell, as you can see. In Python, this could be the equivalent to creating a string with nothing in it, or removing the contents of a string. For SQL, again, inserting a string with nothing in it. Is that it has been created, but there's no real clarity on why the value is not there. And then the last one, missing. The way I like to think about missing is that the attribute doesn't exist. No, seriously, that's all there is to this one. Typically, why we see missing in FME is because when we look at the table view in the inspector, it is a global view. It is all of the unique columns that have been found across the entire dataset, but that doesn't mean that every single record in that dataset has each of those attributes. If you have a look at that bottom one that has missing, the reality is that that feature does not contain that attribute something, where the other two do. It's just because it's being represented in a global view that it has to have a column there, and the way that we sort of clarify that it doesn't have that value is by tagging it as missing. Now, though it's important to understand these null types, this transformer is not explicitly limited to mapping null types. This transformer does not require the selection of null types as part of its mapping. We can actually do all kinds of different mappings. For example, we could map various representations of data types to the correct representation. Common one I do is I take a T or an F, and I actually map that to SQL true or false so that I can slap them into an insert statement. You can also use this to correct various representations of nothing if you want into an FME supported form. If you ever worked with mapinfo, -9,999 is null in mapinfo. Or you could even try and correct user-worded representations like people putting in NA or none or etc. Or values that you don't accept as a valid value, so you want to map them to null. There's lots you can do here. And to take this a step further, this transformer has some really good conditional attribute value support. And it means that you can do very diverse mapping criteria through conditional statements. Instead of very simply saying, is my attribute value A, or does my attribute value contain regex B, you can actually have, does my attribute contain value A, or value B, or value C, or does it contain value C plus B? Does my attribute contain any of these regexes listed based on a whole selection of criteria? And not only can you do that on the input mapping, but you can do that on the output of the mapping too. You can have different attribute outputs, values, based on the states of the feature. If these were true and the mapping was true, then I have value A. Or if these were true and this part of the mapping was true, then I have value B. It's actually incredibly complex and diverse. And this is why I think this transformer is misunderstood, is that people treat it very much as I have a null and I want that to not be a null, or vice versa. The reality is that you can do very complex, robust mapping functions with this transformer if you give it the chance. The next transformer that I'm going to talk about is another transformer that I think is misunderstood, and that is the vertex creator transformer. A transformer that appends vertices to features in a number of different fashions. And this can be as simple as just replacing an existing geometry with a point. Spoiler, that's the one I think that everyone gets focused on. Append vertices at the specified coordinates on the provided feature, insert vertices at specified coordinates in the provided feature at a specified index, and replace vertices at the specified index of an input feature with the specified coordinates. It's actually a fairly complex transformer. Where I think the problem is that people treat it like it is the point creator transformer, that the point of this transformer is to create points. Replace your existing geometries with points. We feed in features that are not points, and what we get out is points. And if what we got out was not a point, we don't want it. It's the most common use case I see of this transformer, and I think it's actually somewhat misguided. And where I see people using it like this the most is where they have a tabular data set, and they've got longitude and latitude values, and they feed them into their vertex creator, and voila, they get points. And look, that's fantastic. That's a great use for it. Except that we can actually do the same thing directly at readers. If you have a CSV reader or an Excel reader or some other tabular-based format, you can actually specify the coordinate system at the reader, and in the attribute definitions through the parameters, for those longitude and latitude values, you can actually set them as a X coordinate, Y coordinate, or Z coordinate if you've got an elevation type. And what that will tell FME to do is to actually interpret those as the longitude and latitude values for your points and create the points at the reader. It actually does the exact same thing, and it does it without needing the transformer. So does this make the transformer sort of irrelevant? Absolutely not. As per my first slide, there's actually quite a few different things that you can do with this transformer. And it's these things that I'm about to talk about that I think people overlook. The next mode to talk about is the add point mode. Adds a vertex to the existing geometry provided. This one does not actually replace existing vertices in the input geometry, unlike the replace point mode that people normally use. And what it can do is it can actually potentially update geometry definitions depending on what you provided and where you add a vertex. And if you have a look example on the right, If we've got nothing and we add a point at 0, 0, we get a point. If I add another point to that after, I get a line. I add another point after that, I get a second line, so I've still got a line geometry in total. And then I add another point at the same place as my original point, and I've closed the polygon. It is now a polygon, all done with the same single vertex creator. This transformer, depending on what you feed it, can create points, lines, or polygons. Again, not the point creator. Another one to talk about is inserting points at indexes. Inserts a point at the X, Y, and Z, if you've got them coordinates, into geometry at a specified index. Again, this does not replace existing vertices in the input geometry. This behaves very much like that previous mode, where it does potentially update geometry definitions depending on the input feature and added vertex. You can create points, you can create lines, you can create polygons with this. But this one has a lot of interesting use cases because unlike the previous one that only appends to the end, this one can be inserted at any point in amongst your existing vertices. And so an example on the right, let's say you've got a rough building footprint that has an alcove in it, but that alcove has not been drawn correctly. It's triangular for whatever reason. I can insert a couple of extra points and actually make that the squared out alcove that it should be. And then the last one to talk about, replace point at index. So this one replaces the current vertex at the specified index with a new vertex that has the coordinates specified. Now this one does replace existing vertices in the input geometry. You are specifying one to replace, to move effectively. And it doesn't actually update the geometry definition in the same manner that the add functions do because you're not adding additional vertices, you're just revising existing ones. But using that same building footprint as an example, instead of squaring out the alcove, what I can do with this function is that I can actually nominate that vertice that is making the triangle and pull it down to be in line with the other vertices, as another example. So this is the point that I want to get across with this transformer, is that it is not the point creator transformer. This vertex creator creates or replaces vertices. It can create points, it can create lines, it can create polygon geometry definitions. It can be used to correct geometry, to close polygons. You could snap assets together with it if you've got, say, line assets that are misaligned, all sorts of things. The point is that it is not all about points. Thank you very much. I'm going to hand you over to the